In this lecture, we're going to learn about auto function templates. And this is a syntax we have to simplify how we set up our function templates. And the syntax is what you see here. You say auto, that's going to be a return type as you see here. You say the function name, and then you specify your parameters using auto here. When you do something like this, the compiler will know that it will have to deduce the return type, the first parameter, and the second parameter. And behind the scenes, really, the compiler is going to generate a template that looks like this. So it's going to have type name T and P, which are going to be placeholders for the parameters that we pass to the function when we call it. And the return type is going to be automatically deduced from the parameters that we pass. So this is something you will definitely see out there, and I wanted you to be aware of it. And if you don't want to see these template declarations in your code, you can use this and it is going to work. Okay, now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is auto function templates. We're going to grab our template files here and put them in place. And we're going to open this in Visual Studio Code pretty quick by dragging and dropping on top of Visual Studio Code here. This is going to open our folder. We can clean up the main CPP file and close the left pane here. What we want to do is to put in our function. And it is ridiculously easy. So for example, suppose we want a function that is going to add two numbers that you pass to it as arguments. We can say auto func add, why not? And it's going to add two parameters, auto A and auto B. Okay, we can do this, and then we're going to return A plus B. This function will work on any parameter that you pass to it. If you pass int and double, it's going to add those up, and then it's going to deduce the return type based on the expression here. And it is going to basically use the largest type involved in this expression as the return type. So if, for example, we have int A and put in a 7 and have double B and put in 78.2, why not? And then we compute the result, say auto result. We're going to say func add, and we're going to add up A and B. Try to guess the return type we're going to get here. Okay, try to guess it. And here we have a compiler error. What is the problem with our Visual Studio Code instance here? More than one instance overloaded for function add. Let's try and build this. Let's pass this through the compiler and see what we get. And you see the build is good. It is just Visual Studio Code messing with us here. This is going to work. So now we have the result. What we can do is print it and see what the compiler actually deduced as the return type here. We know that it is going to use the largest type because that's what compilers do when they need to deduce the type of the expression. And it is what is going to happen here. So we're going to print result here, and let's do that. And we're going to print the size of the result. This is one way we have to prove the return type. Okay, now that we have this, we can build with GCC again and see what we get. The build is good, so we can clear and run Rooster and see what we get. We get our maximum, which is 85.2, so that's the sum of A and B, but the return type is deduced to be double because that's the largest type in our return expression here. So I have said before that this is really going to generate a function template behind the scenes. And I want to show you that function template. We have seen something like that before. So let's try and come up with that. Let's comment this out and show you that it is going to work equally well. So what the compiler is going to generate when it sees a function like this with auto, it's going to generate a function template. So this function template is going to be something like this. Type name T, for example, type name, and then it's going to automatically deduce the return type. And one way, which is simpler, we have seen to do this, is use decal type auto. So let's do that. And we're going to say func add, okay, the name of the function. So we're going to take the first parameter as T type, and the second parameter is going to be of P type. Let's say A and B here, just to be consistent. And we're going to return A plus B, okay? If we do this, you see that Visual Studio Code doesn't have a problem. And if we build and run the code, we are going to build successfully, clear run rooster, we have the exact same thing. So let's prove that this is actually going to generate a function template instance using the arguments that we passed in here. And one way we saw we could prove these things is through a tool like CPP Insights. So I am going to grab the entire code that I have in here, and I am going to hop over to my browser. I'm going to take out everything I have in CPP Insights here, and I'm going to paste in my new code. You see, it is what we had in Visual Studio Code in a minute, our function template, the main function, and nothing really complicated here. So we have this function template, and we are calling the function with these arguments. It's going to generate a template instance which takes the first parameter to be int, because that's what we're passing in here. The second parameter is going to be double, because that's what we're passing in here. And the return type is going to be automatically deduced to be double, because the largest type involved in this expression here is of double type. Let's hit the run button to see what the compiler generates. Let's look here. So we have our function template, and starting at line 9 here, you see that we have a template instance generated. It's going to take the first parameter as int. It's going to take the second parameter as double, and it's going to return double. And you see that the return type is being cast back to double. And you see that in our return statement, the compiler is going to cast our int to double so that we can return double from this function here. Hopefully you can see that this is going to generate a function template instance. But the real thing we want to see in this program is that if we use our auto function here, it's also going to do the same thing we have here as if we use the function template. And hopefully this is going to prove that the compiler is going to generate something like this when it sees you use the syntax like this in your code. So all we have to do is hit the run button here to see that what we have to the right here doesn't really change. So we have our function here, which is using the auto syntax, but you see that the function template instance we generate is really the same. So hopefully this proves that when you use a syntax like this, the compiler is going to generate a function template behind the scenes, and a template instance will be generated depending on the parameters you call your function with. This is really all I wanted you to see in this lecture. And please do use this syntax when it makes sense for your application. We're going to comment out our function template syntax here because the purpose of this was just to show you that we go through this. When we put this in our code, the compiler is going to generate this behind the scenes, and we're just going to have a nicer syntax to use without all these template declarations that we have here. So if you don't like them, this is something you might use to have a nice piece of code to look at, and the compiler is going to handle all these templates behind the scenes for you. Okay, this is really all we set out to do in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to see how we can use named template parameters with templated Lambda functions. Go ahead and finish up here and meet me there.